Mobile hardware. About this module. Mobile devices and the hardware that powers them have enabled computing on the go. Mobile hardware enables users to conduct business from anywhere, easily stay in touch with friends and family, search for news, enjoy videos and books, and even monitor their health. Welcome to the mobile hardware module. In this module, you'll explore the hardware that makes up mobile devices and how it differs from desktop hardware. You'll learn about mobile hardware components, including the types of display technologies. You'll follow the process IT support technicians use to set up and configure a new business laptop and its network connectivity. You'll learn about mobile accessories and ports. Then, you'll get an overview of the symptoms that indicate issues with mobile hardware and software, as well as special considerations for mobile network connectivity. And finally, you will learn the steps to troubleshoot mobile hardware, software, and network issues. About this lesson, Introduction to Mobile Hardware. In today's world, mobile devices have become an integral part of daily life. But have you ever wondered about the components that make them work? Mobile hardware components are the building blocks of smartphones, tablets, and other devices people use all the time. From the colorful screens that provide entertainment to the networks that enable communication, all these pieces come together to make mobile devices function and support amazing things with technology. In this lesson, you'll learn about the impact of mobile hardware and the differences between mobile and desktop hardware. You'll explore common mobile hardware technologies and components. You'll also learn about different types of display technologies and their settings. Overview and impact of mobile hardware. Mobile computing has had a tremendous impact on the global economy and general productivity, or how much work we can all produce. Mobile devices are smaller and more portable than desktop computers, making them easier to use in almost any situation. Mobile hardware is also available at costs that can be far lower than the costs of a full desktop computer. This difference has made computing accessible to millions of people. Mobile hardware refers to the physical components of mobile devices, such as smartphones, tablets, and laptops. Mobile hardware components include processors, memory, storage, screens, batteries, and sensors. Select each card to learn more about the impact of mobile hardware on computing. Universal presence. The universal presence of mobile hardware is evident in the billions of people using mobile devices and their hardware components as an essential part of everyday life. These devices enhance communication, entertainment, navigation, and productivity. Innovation. Mobile hardware continues to push the boundaries of technology with improvements in processing power, battery life, and connectivity. Mobile hardware enables new applications and services, such as augmented reality and advanced health monitoring. Economic impact. The mobile hardware industry drives global economic growth, creating jobs, fostering innovation, and generating significant revenue across the manufacturing, sales, and service sectors. You have likely experienced the impact of mobile hardware in your personal life. You might even be viewing this module on a mobile device. Next, you'll explore factors that IT support technicians and organizations need to consider with mobile hardware. Mobile hardware in organizations. In the world of mobile hardware, IT support technicians work with users to troubleshoot issues on their personal devices. They can also work with employees at organizations to troubleshoot issues with business mobile devices. Mobile devices are critical and impact business computing in many ways. These devices make it possible for employees to access company data and collaborate anywhere in the world. Increased efficiency allows for flexible work hours and greater productivity, and reduces the need for physical office space. Mobile hardware also facilitates better communication between teams by enhancing responsiveness to team members and customers. Many organizations provide mobile devices, such as laptops, to their employees as well as implement Bring Your Own Device (BYOD) policies. BYOD policies are a set of rules and guidelines that allow employees to use their personal mobile devices for work-related purposes. BYOD policies can define how an employee can access company resources, data, and applications and what devices can be added to an organization's network. To implement mobile devices, IT support technicians in organizations must adopt new strategies and tools that ensure security and compatibility with existing systems. Select each section to learn more about considerations for IT support technicians regarding mobile devices in organizations. Mobility and flexibility. Mobile devices enable employees to work remotely by providing flexibility and efficiency. IT support technicians must provide effective support for mobile and remote users. Integration and support. Mobile devices enable users to access company software and applications across multiple devices. IT support technicians must ensure that mobile devices integrate with existing enterprise systems. Device management. Mobile devices enable users to access company data that can require management. IT support technicians must implement and manage mobile device management (MDM) programs to address provisioning, monitoring, and compliance with corporate policies. Security concerns. Mobile devices can be a weak link in the organization's security. IT support technicians must understand and manage security protocols related to mobile hardware to protect sensitive data. For an IT support technician, mobile hardware requires crucial areas of expertise that include customer support, security, integration, implementation, managing access to data, and customer support. By focusing on mobile hardware, a future IT support technician can prepare to face the challenges and opportunities in the ever-evolving landscape of modern technology. Activity, benefits and challenges of mobile hardware in the real world. Mobile hardware has introduced users to diverse opportunities, but it also presents IT support technicians with new challenges. In this activity, you'll review a scenario to better understand the benefits and challenges of using mobile hardware. Afterward, you'll answer a question about what you learned. The desktop expert. Sebastian, a seasoned IT support technician, has spent years refining his expertise in troubleshooting desktop devices. His typical workday involves working closely with employees in the office, being hands-on with their hardware, and physically examining issues. New Horizons, BIOD. The organization Sebastian works for, recognizing the potential benefits of mobility, introduces a Bring Your Own Device, BIOD, policy. The idea is appealing as it offers enhanced flexibility, accessibility from various locations, and the ability to work on the go. Employees quickly adopt this new policy, embracing the use of personal mobile devices for work purposes. Sebastian finds himself in unfamiliar territory. Suddenly, he's not just dealing with desktops but a range of tablets, smartphones, and other mobile devices, each with different operating systems, configurations, and security concerns. Panic in a remote world. One day, an employee is unable to access a critical file during an out-of-town meeting, and there's no physical way for Sebastian to reach the device. Panic sets in as deadlines loom. The entire process of troubleshooting that used to be a walk across the office now feels like a journey into unknown territory. Adapting and evolving. Sebastian quickly realizes that his traditional tools are not enough to face these new challenges. He must adapt, learn to utilize remote troubleshooting tools, become familiar with various mobile platforms, and find ways to secure personal devices accessing company information. Mastering the mobile realm. Sebastian invests time in training, exploring new methodologies, and embracing a mindset that goes beyond his comfort zone. Slowly, he masters the art of remote support, becoming proficient in managing a variety of mobile issues. The organization and its employees reap the benefits of the BIOD policy, and Sebastian grows in his role, proving that adaptability, continuous learning, and a willingness to embrace change can lead to success in the dynamic world of modern IT support. Mobile computing introduces new challenges and opportunities for IT support technicians by requiring a broader skill set for managing and supporting this evolving technology landscape. What do you think? Employability skills. Critical thinking. A challenge that Sebastian faced was that the employee was no longer in the same physical location as he was. What other challenges might an IT support technician encounter when assisting an employee working remotely on a mobile device? Evaluate your thinking. Does your answer account for the following? Without physical access to a device, a technician might have difficulty accurately assessing and diagnosing the issue. There might also be logistical issues if a technician believes the issue is hardware-related and can only be resolved physically. Coordinating a physical meeting or having the employee ship the device might be difficult. There might be time zone differences, or the device might need to be sent to the technician. These factors can lead to significant downtime for the employee, which might impact productivity and ability to meet deadlines. Key differences between mobile and desktop hardware. How is mobile hardware different from desktop hardware? Engineers design mobile hardware for portability and flexibility. These characteristics enable users to perform tasks, access information, and collaborate on projects from various locations. Mobile hardware provides on-the-go computing. Let's explore the differences between desktop and mobile hardware. Select each card in the following sections to compare desktop and mobile hardware. Portability. Mobile hardware is designed to be carried around. Mobile devices can be ideal for working on the go. Desktop hardware is stationary. Power consumption. Mobile hardware typically uses less power by relying on batteries that are designed for efficiency. Desktops are usually connected to a power supply unit. Performance. Mobile hardware is optimized for balance between performance and energy efficiency. Desktop hardware usually offers more robust performance because of its more powerful components, the ability to dissipate heat more effectively, and greater access to power. Customization. Mobile hardware components are integrated into the device, which means that they cannot be easily replaced or customized. Desktops are typically built from separate components, making them more customizable and upgradable. Interface and usability. Mobile hardware often includes touchscreens and other sensors that provide different ways to interact with it. Desktops rely more on traditional input devices such as a mouse and a keyboard or dedicated peripherals such as graphic tablets and pen interfaces. Now that you've explored the differences between mobile hardware and desktop hardware, let's explore the different types of mobile hardware components. Mobile hardware. Watch the video about different types of important mobile hardware components that power mobile devices. Afterward, you'll answer a question about what you learned. Page 1 of 2. Video transcript. Mobile hardware. Welcome to the busy office of Sudamo, Inc. Here, Johan is the IT support technician who manages the company's bring your own device, or BYOD, policy. This means Sudamo employees can use their personal smartphones, laptops, and tablets at work to communicate and stay connected. Let's explore the world of mobile hardware, where display technology captivates the eyes, cameras capture critical moments, and wireless connectivity and batteries keep the workforce on the move. Display technology is a key component of mobile hardware. Liquid crystal display and organic light emitting diode are two common display technologies for mobile devices. Liquid crystal display, or LCD, is a common type of display technology for mobile devices and laptop computer monitors. LCD displays use a liquid crystal solution in a color filter sandwiched between two layers of glass to control the passage of light that comes from a backlight to create an image. OLED, which stands for organic light emitting diode, is another display technology. Unlike traditional LCD displays, OLED pixels can produce their light independently. This self-illuminating property of OLED displays contributes to their better image quality and contrast compared to other display technologies. Understanding the differences between display technologies can help Johan troubleshoot issues that employees may have with a display. For example, if an employee reports that their device's display appears washed out or has poor contrast, Johan can use his knowledge of display technology to diagnose the issue and provide a solution. With Sudamo's remote work policies and increased use of virtual meetings, Johan often helps employees with the camera on their laptops and tablets. The camera is a mobile technology that many users depend on. Mobile camera technology has evolved significantly over the years, with features like higher resolution, image stabilization, and low light performance becoming increasingly important. Whether Sudamo employees are in the office, or working from home, they depend on wireless connectivity on their mobile devices to get their work done. Wireless connectivity includes Wi-Fi, Bluetooth, and near-field communication, or NFC, to allow employees to connect to the Internet and communicate with others. Wi-Fi is a wireless networking technology that allows devices to connect to the Internet or communicate with each other over a local area network or LAN. Mobile devices have wireless network cards that allow them to connect to a Wi-Fi network. Bluetooth is a short-range wireless technology for exchanging data between devices over short distances with low power consumption. Mobile phones and other Bluetooth-enabled devices have a special chip that allows them to connect via Bluetooth. Page 2 of 2. Near-field communication, or NFC, is a short-range wireless technology that allows devices to exchange data by simply touching them together or bringing them into close proximity. Mobile devices also use special chips for near-field communication. On some mobile devices, cellular connectivity, including 4G and 5G networks, is a way Sudamo employees can stay connected on the go. These networks ensure their devices remain connected when Wi-Fi is unavailable. A cellular modem and antenna allow devices to connect to cellular networks. They communicate with cellular towers and other network infrastructure. They translate data between the device and the network, ensuring that the device can send and receive data over the cellular network. Sudamo employees must be able to rely on their devices throughout the day, and batteries keep the mobile hardware components running. The most common type of batteries in modern mobile devices are lithium-ion, or Li-ion. They are lightweight, compact, and offer high energy density, making them well suited for smartphones and tablets. Li-ion batteries store and release energy by moving lithium ions between the two ends of the battery, called the anode and cathode. This movement of ions enables the battery to charge and discharge efficiently. You can see that mobile hardware is crucial for Sudamo employees to stay connected and be productive. As Johan continues to manage their mobile devices, he knows that keeping up with the latest developments in mobile hardware is essential for ensuring a smooth and seamless experience. Think about a mobile device that you might own and use in your daily life. What are some activities that you use the device for, and what hardware components allow you to perform the activities? Critical thinking. Evaluate your thinking. Does your answer account for the following? Some common ways you might use mobile devices include: you can communicate via phone or text using cellular connectivity, including 4G and 5G, and cellular modems, which enable phone calls and text communication. You can do work for school or your job on the go because batteries keep mobile devices charged and running. You can take photos with camera technology and mobile storage, which allow you to take and save photos on your mobile devices. You can watch videos with display technology like LCD and OLED, providing you with the ability to watch clear, colorful videos on smaller mobile devices. Mobile hardware components. You'll find that mobile hardware includes a broad and complex array of technologies and components. Mobile hardware components work together to provide users with the power of communication, entertainment, and productivity. Select each section to learn about mobile hardware components. Mobile displays. Mobile displays come in various technologies and formats, including liquid crystal display, LCD, organic light emitting diode, OLED, active matrix organic light emitting diode, AMOLED, electronic ink, e-ink. These technologies differ in aspects such as color reproduction, energy efficiency, and viewing angles. Touchscreen functionality is a common feature in modern mobile displays. It allows for direct interaction with the device. Physical buttons and interfaces. Physical buttons on mobile devices typically include power, volume control, and home buttons. On laptops and some mobile phone models, physical buttons also include the keyboard. Interfaces such as Universal Serial Bus Type-C, USB-C, Lightning cables, and headphone jacks provide connections for charging, data transfer, and audio output. The design and layout of these buttons and interfaces can vary significantly between different devices and manufacturers. Cameras and audio components. Mobile devices typically include both front and rear cameras with features including varying resolutions, optical zoom, image stabilization, artificial intelligence, AI, enhanced functionalities. Audio components on mobile devices typically include the following: built-in speakers, microphones, headphone connections. These features enable functions like voice commands, video conferencing, and multimedia playback. Batteries and charging technologies. Mobile devices typically rely on lithium-ion or lithium polymer rechargeable batteries as their primary power source. These batteries are designed to provide energy efficiency and enough power to last through typical usage patterns. Charging technologies have evolved to include fast charging, wireless charging, and energy-saving modes. Wireless connectivity technologies. Wireless connectivity in mobile hardware includes technologies like Wi-Fi, Bluetooth, near-field communication, NFC, mobile network connections, such as 4G and 5G. These technologies enable internet access, data transfer, and communication with other devices and networks without physical connections. Sensors. Mobile devices are equipped with sensors to enhance functionality and user experience. Common sensors include accelerometers for detecting device orientation, gyroscopes for detecting rotation, global positioning system, GPS, for location services, ambient light sensors for adjusting display brightness, biometric sensors, such as fingerprint or facial recognition for security. Mobile hardware encompasses a broad and complex array of technologies. Each component contributes to the device's functionality, usability, and overall user experience. Understanding mobile hardware is vital for anyone working with mobile devices, whether you're a user, a developer, or an IT support technician. Comparing mobile device displays and settings. Imagine that you step into an electronics store, ready to purchase a new smartphone that complements your passion for photography and travel. You pick up a device that has full HD, 1080p, resolution and a large 7 screen. The colors are vibrant, and the text appears sharp. Another smartphone catches your eye, featuring a 4K display, but a slightly smaller 5.5 screen. The sample images are incredibly sharp. Finally, you pick up a smartphone that is foldable and features an OLED screen that is 7.6 when fully open. You see all the details regarding the display technologies, resolution, and display size, and your head begins to spin. How do you decide which phone is going to be best for you? You've learned that there are many hardware components to consider when choosing a mobile device, and one of the most important factors is the display. Mobile device displays offer unique characteristics compared to desktop displays because they can be used for both viewing and interacting with content. There are 4 types of mobile display technologies. 1. Liquid crystal display, LCD. Screens use a backlight panel that emits light to illuminate pixels, and a layer of liquid crystals that are manipulated to control the passage of light. The liquid crystals act as a shutter, allowing light to pass through or be blocked, creating images on the screen. 2. Organic light emitting diode, OLED. Screens consist of organic compounds that emit light when an electric current is applied. Each pixel in an OLED screen emits its own light, allowing for individual pixel control and producing vibrant colors and deep blacks. 3. Active matrix organic light emitting diode, AMOLED, is a type of OLED display that uses an active matrix to control each individual pixel. This provides finer control over pixel behavior, resulting in improved image quality and response times. 4. Electronic ink, e-ink. Screens consist of microcapsules filled with tiny particles suspended in a clear fluid. The particles have a positive charge on one side and a negative charge on the other. These microcapsules are between transparent electrodes. When a positive or negative electric field is applied to the electrodes, the particles move in response. This movement causes the particles to rotate and display different shades of black and white. By controlling the charges applied to the electrodes, the display can achieve various grayscale levels. E-ink is known for its low power consumption and its capability to sustain an image with minimal power usage. Mobile devices can come with any of these types of displays. You will need to be familiar with the types of display technologies specific to mobile devices and their typical settings. Let's explore this. This table provides a comparison between different types of mobile device displays. Notice that this is a high-level overview, and some displays will have variations and combinations of these features. Comparing mobile device display types and settings. Mobile display technologies. There are 4 types of mobile display technologies. Liquid crystal display, LCD, screens use a backlight panel that emits light to illuminate pixels, and a layer of liquid crystals that are manipulated to control the passage of light. The liquid crystals act as a shutter, allowing light to pass through or be blocked, creating images on the screen. Organic light emitting diode, OLED, screens consist of organic compounds that emit light when an electric current is applied. Each pixel in an OLED screen emits its own light, allowing for individual pixel control and producing vibrant colors and deep blacks. Active matrix organic light emitting diode, AMOLED, is a type of OLED display that uses an active matrix to control each individual pixel. This provides finer control over pixel behavior, resulting in improved image quality and response times. Electronic ink, e-ink, screens consist of microcapsules filled with tiny particles suspended in a clear fluid. The particles have a positive charge on one side and a negative charge on the other. These microcapsules are between transparent electrodes. When a positive or negative electric field is applied to the electrodes, the particles move accordingly. This movement causes the particles to rotate and display different shades of black and white. By controlling the charges applied to the electrodes, the display can achieve various grayscale levels. E-ink is known for its low power consumption and its capability to sustain an image with minimal power usage. Mobile devices can come with any of these types of displays. You will need to be familiar with the types of display technologies specific to mobile devices and their typical settings. Let's explore this. The following table provides a comparison between different types of mobile device displays. Notice that this is a high-level overview, and some displays will have variations and combinations of these features. How to read the table. Display technology describes the underlying technology of the display, such as OLED or LCD. Resolution refers to the number of pixels on the display. Higher resolutions generally provide a sharper image. High definition, HD, is a display resolution of 1280 x 720 pixels. Full high definition, Full HD, is a display resolution of 1920 x 1080 pixels, increasing the number of pixels in both horizontal and vertical directions compared to HD. 4K is a display resolution that is either 3840 x 2160 pixels or 4096 x 2160 pixels. Pixels per inch, PPI, is a resolution metric that is used in conjunction with other factors to describe a screen's overall quality. Aspect ratio describes the proportional relationship between the width and the height of a display, such as 16:9 or 4:3. Size indicates the diagonal screen size measured in inches. The pros and cons section provides the general advantages and disadvantages of each device type. Common settings refers to the customizable options that users might find in their device settings. Mobile device display types and settings comparison. 1. Smartphones. Display technology and size. smartphones typically measure between 5 to 7 inches and utilize OLED, LCD, or AMOLED display technologies. Resolution: their resolution can be HD, Full HD, or 4K, with a pixel density, PPI, ranging from around 200 to over 450, and common aspect ratios including 16:9, 18:9, and 19.5:9. Pros and cons: the advantages of smartphones are their high resolution, touch-enabled interfaces, and high portability, though their size can sometimes limit usability. Common settings: typical user settings include brightness, night mode, and color balance. 2 tablets. Display technology and size: tablets generally have screen sizes ranging from 7 to 15 inches and feature LCD, OLED, or AMOLED screens. Resolution: their screens can support HD, Full HD, or 4K resolutions, with a PPI between 150 and 300, and aspect ratios of 4:3, 16:10, or 16:9. Pros and cons: they offer a larger screen, a touch-enabled interface, and are excellent for media consumption, but they are less portable than smartphones. Common settings: users can typically adjust brightness, choose display modes, such as reading mode, and manage color calibration. 3 smartwatches. Display technology and size: smartwatches are equipped with small 1 to 1.5 inch displays that use either OLED or AMOLED technology. Resolution: they usually feature a resolution of around 240x240, a PPI between 200 and 400, and an aspect ratio that is often 1:1 but can vary widely. Pros and cons: while these displays are highly power efficient, their small size inherently limits content viewing. Common settings: common customizable features include brightness, always-on display, and sleep mode. 4 foldable phones. Display technology and size: foldable phones utilize flexible OLED or AMOLED technologies, resulting in a variable size depending on whether the device is folded or unfolded. Resolution: they can reach Full HD or 4K resolutions, feature a PPI between 300 and 400, and have an aspect ratio that varies significantly due to their foldable design. Pros and cons: they offer a highly flexible screen size and are touch-enabled, but they come with durability concerns and a higher financial cost. Common settings: available settings usually include display size adjustment, screen refresh rate, and aspect ratio controls. 5 e-readers. Display technology and size: e-readers typically range from 6 to 9 inches in size and strictly use e-ink display technology. Resolution: they generally have a resolution around 800x600, a PPI ranging from 150 to 300, and a 4:3 aspect ratio that is optimized for a book-like reading experience. Pros and cons: e-ink displays mimic real paper, help prevent eye strain, and offer long battery life. However, they are typically monochrome, though color options exist, limited for multimedia use, and suffer from a slow refresh rate. Common settings: users can commonly adjust the font size, contrast, and reading mode. Now that you've learned about how mobile devices use different displays, let's explore some challenges that IT support technicians face when working with different display types. Display types and IT support. The diverse range of mobile device displays, with their varying sizes, resolutions, and underlying technologies, creates challenges for an IT support technician. IT support technicians can encounter one or more of the following challenges when supporting different mobile devices with various display technologies. Resolution and size considerations. Problem solving: different resolutions and screen sizes might affect how systems render applications and websites. Accessibility: IT support technicians might configure settings such as brightness or font size to meet individual needs. Technology differences. Maintenance: technologies like LCD, OLED, or AMOLED have varying maintenance requirements, repair complexities, and costs. Calibration: depending on the technology, technicians might configure settings such as color balance or contrast to ensure a consistent visual experience across devices. Unique display types. Foldable phones. These mobile devices require specialized knowledge for repair, maintenance, or configuration due to their unique construction. E-readers. Because these devices are specific for reading, technicians need to be familiar with their unique settings. Compatibility issues. Software. Not all software is compatible with all screen types, sizes, or resolutions, which creates potential challenges in deployment and troubleshooting. Peripherals. Some mobile displays require specific accessories, such as styluses, that IT support must manage and configure. Next, you'll use your knowledge of display types to evaluate mobile device displays based on a user's needs. Activity. Choose a mobile display based on user needs. Employability skills. Critical thinking. In this activity, you are an IT support technician intern shadowing Tanya, an experienced technician. Tanya is helping Sasha, a realtor, choose the best mobile device for her needs. Sasha's work relies heavily on taking high-resolution photos of properties and showcasing them to potential clients on her smartphone. When she shares photos of homes using her current phone, the display lacks clarity and vibrancy. She turns to you and Tanya to help her find a suitable replacement. Together with Tanya, you'll evaluate different mobile device display factors to make the optimal choice by reading through the scenario and answering questions. You can use the mobile device display types and settings resource that you downloaded to help you complete this activity. Understanding needs. You and Tanya begin by revisiting Sasha's specific needs. The device display must meet the following criteria. Ability to display high-resolution images. Vibrant colors. Excellent viewing angles. These display requirements are essential for allowing Sasha to present properties in the best possible light. Evaluating display technology. Tanya and you explore LCD, OLED, and AMOLED display technologies because these are commonly used in smartphones. You learn that LCD screens use a backlight panel that emits light to illuminate pixels, and OLED and AMOLED screens consist of organic compounds that emit light when an electric current is applied. Zooming in on resolution. Recognizing the importance of image sharpness for Sasha's work, Tanya scrutinizes resolution options. She narrows her search to devices that offer Full HD or 4K resolutions. Full HD has a resolution of 1920 x 1080 pixels, providing a good balance between clarity and performance. On the other hand, 4K screens have pixel dimensions of either 3840 x 2160 or 4096 x 2160, delivering 4 times the resolution and detail, but often at the cost of increased power consumption. Considering size. Screen size is the next variable on Tanya's evaluation sheet. Screen dimensions range widely, but she believes a device with a screen size between 5.5 and 6.5 inches would be ideal for Sasha. This size range strikes a balance between a sufficiently large display for intricate property details and a manageable size for portability. Exploring settings. Tanya also evaluates the common settings available in potential devices. You and Tanya know that certain settings can have a significant impact on image appearance. Because most of Sasha's work is on the go, her light conditions vary greatly from well-lit office spaces to dim indoor spaces. Balancing budget and needs. Last but not least, Tanya considers the budget. Although it's crucial to meet Sasha's requirements, it's equally important to stay within the company's spending limits. Tanya compares the costs and benefits of each suitable device carefully. Conclusion. After a thorough evaluation and careful consideration, you and Tanya decide that a smartphone with a 6.3-inch AMOLED display and 4K resolution would best meet Sasha's needs. The AMOLED technology offers the vibrant colors and deep blacks essential for the realtor's work. The 4K resolution ensures clarity, and the screen size strikes the optimal balance between viewing and photography. Additional features such as adjustable brightness and color balance add to the device's appeal. The decision-making process you and Tanya used reflects a methodical and user-centered approach. By focusing on Sasha's specific needs and the technical aspects of various display technologies, you ensured that the chosen device enhances Sasha's ability to engage clients with stunning visual presentations. This choice illustrates the essential role IT support technicians play in not only understanding technology, but also tailoring it to meet individual and professional needs. In this lesson, you learned about mobile hardware and its impact on computing. You explored the differences between mobile and desktop hardware. You examined common mobile hardware components and display technologies for mobile devices. You also reviewed a real-world scenario in which an IT support technician selected a mobile display based on user needs. The next lesson covers setting up and configuring mobile devices, such as laptops and accessories for mobile hardware. About this lesson, configure mobile devices and accessories. In this lesson, you'll learn about the process to set up and configure mobile hardware, such as a business laptop. You'll learn about common mobile accessories and various ports that mobile devices use. Finally, you'll learn the steps to configure wired and wireless network connectivity for mobile devices. Setting up and configuring laptops. IT support technicians often set up and configure new mobile devices for users that they support at their places of business. Technicians not only set the devices up, but they also ensure that the system aligns with organizational policies, user needs, and security requirements. Let's focus on a laptop. To successfully set it up and configure it properly, an IT support technician must demonstrate attention to detail, follow company protocols and regulations, and have clear communications with the employee. Introduction. Learn about the typical steps you would take as an IT support technician to set up and configure a new laptop for a user at a business. These steps, for the most part, also apply to setting up a personal laptop. Step 1. Task: unbox the laptop and components. Unbox the laptop, carefully remove the laptop and accessories, such as the power adapter, ensuring that everything listed on the packaging is included. Check hardware: inspect the laptop for physical damage, focusing on features like the screen, the keyboard, and the ports. Connect peripherals: connect a mouse, keyboard, monitor, or any other peripherals that the user needs. Plug in the power adapter. Step 2. Task: configure the basic settings and connect to a network. Power on the laptop, press the power button to start the initial setup process. Select language and region, choose the appropriate language, time, and currency formats. Connect to a network: connect to a Wi-Fi or wired network as required by the operating system, OS. Sign in or create an admin account, depending on the OS, sign in with or create a new account. Step 3. Task: configure the operating system and laptop settings. Set up the OS, follow the OS-specific setup instructions for Windows, Mac OS, or Linux. Install updates: install any necessary updates to ensure that the laptop has the latest security patches. Configure settings: adjust system preferences such as display settings, power options, and accessibility according to the user's needs. Step 4. Task: install software and security measures. Install required software, based on the user's role and needs. Install essential applications such as the Microsoft Office suite, web browsers, and collaboration tools. Set up antivirus and security: set up security software to protect against malware and unauthorized access. Step 5. Task: configure networks for business. Join a domain, connect the laptop to the appropriate business domain, following company protocols. Configure a virtual private network, VPN: set up a VPN if the user's needs include remote access to the company network. Step 6. Task: personalize preferences and accessibility. Personalize the environment, customize the OS, the taskbar, or the dock based on user preferences. Step 7. Task: set up backup and recovery. Configure backup solutions, set up automatic backups to ensure data protection. Create recovery media, ensure there are recovery options available in case of system failure. Step 8. Task: ensure company compliance. Ensure compliance. Verify that the setup complies with company policies and any legal regulations. Document the configuration. Maintain a record of the hardware, OS, software configurations, and other essential details for future reference. Step 9. Task: hand off to the laptop user and offer support. Communicate with the user. Contact the user to share that the laptop is successfully configured and ready to use. Supply user training. Provide the necessary training or guides for using the laptop effectively. Offer ongoing support. Ensure that the user knows how to contact IT support for future assistance. Setting up and configuring a mobile device, in this case, a work laptop, for a user involves a series of careful tasks and steps. This process ensures users are set up for success to immediately start using their devices and seek out IT support in the future when needed. Setting up and configuring accessories and ports. Accessories for mobile hardware include items for protection, audio, charging, connectivity, input, and health monitoring. The configuration of accessories varies, ranging from physical attachment to a more complex Bluetooth pairing or app integration. Not all mobile hardware supports every accessory. Accessories can be specific to the type of mobile hardware and the brand. Even so, mobile hardware, in general, supports a broad range of accessories. For example, laptops require the most accessory support from IT support technicians because of their versatility and varied usage scenarios, necessitating a range of peripherals for optimal functionality. To further examine mobile device accessories, let's explore laptop accessories. Select each marker, plus, on the diagram to learn about accessories for laptops. Protective accessories. Cases and covers safeguard devices from physical damage. Screen protectors adhere to the display to protect against scratches and cracks. Wearable accessories. Fitness trackers and smart watches connect via Bluetooth and require app integration, user profile setup, and permissions configuration. Charging and power accessories. Wired and wireless chargers connect to the device via a charging port or alignment with a wireless charging pad. Power banks connect portable batteries via USB or other charging ports. Connectivity accessories. Dongles and adapters allow connections to various interfaces like high-definition multimedia interface, HDMI, or video graphics array, VGA. Cables connect devices to computers, chargers, or other peripherals. Audio accessories. Headphones and earbuds connect via Bluetooth, the data/charging port, or an audio jack. Configuration can involve pairing through Bluetooth settings or plugging into the device. Speakers connect wirelessly or via ports. They can require device pairing or compatibility checks. Input accessories. Keyboards and mice connect via Bluetooth or USB, require pairing or plugging in, and can involve configuring settings such as layout or sensitivity. Styluses connect via Bluetooth. They can require calibration and settings adjustments. Accessories are a key part of mobile devices. As you have learned, some accessories can be connected to a mobile device using wireless technology. But what if an accessory needs to be plugged into the device to function properly? Next, let's explore how ports facilitate these connections. A port is a physical connection point on a mobile device that allows for charging, data transfer, and audio/video output. Understanding both the accessories and the corresponding ports is essential for IT support technicians to ensure compatibility, guide users, and troubleshoot issues. Select each card to learn more about the types of ports that many mobile devices have and their functions. USB ports, including Type-C and micro-USBs, charge devices, transfer data, and connect various peripherals. 3.5mm audio jacks connect wired headphones, speakers, or an external microphone to mobile devices. HDMI ports, including mini and micro, allow video and audio output to external displays. SD card slots expand storage by inserting a micro SD or SD card. Subscribe Identity Module, SIM, card slots house the SIM card for cellular connectivity. Proprietary ports are specific to certain brands, such as the Apple Lightning port. They charge devices, transfer data, and connect accessories. Setting up and configuring accessories and ports on mobile devices is an essential aspect of enabling and enhancing the functionality and user experience of these devices. Whether the task is connecting audio equipment, expanding storage, facilitating charging, or enabling data transfer, understanding the various types of ports and accessories is vital. IT support technicians must be well versed in accessories and ports so they can guide users, ensure compatibility, and troubleshoot any issues that arise. This knowledge not only adds value to the services they provide, but also enables users to maximize the capabilities of their mobile devices. Configuring mobile network connectivity. In the rapidly evolving world of technology, mobile network connectivity has become an integral part of everyday business operations. Whether it's for a multinational corporation or a small startup, configuring network connectivity on mobile hardware enables seamless access to essential resources, data, and online platforms. Network connectivity refers to both wired and wireless connections, each with distinct advantages and requirements. Wired connections often provide faster and more reliable speeds but limit mobility, and wireless connections offer the flexibility of accessing the network from various locations. Like desktop computers, mobile devices use addresses for networking. You know how difficult it can be to locate a new home or business in a new city or village. To find your way, you might use a unique address for that location. Similarly, data finds its way between computers without getting lost by using unique identification addresses, IDs. A hiker checks the map on his smartphone. All network-connected devices have two special IDs. Media Access Control, MAC, addresses. Internet Protocol, IP, addresses. Each mobile device, such as a laptop or cell phone, has a Media Access Control, MAC, address. MAC addresses are globally unique, so no two pieces of hardware can share the same MAC address. Think of a MAC address as a passport number. That number is entirely unique to you and tells authorities that you're you. Devices on a network, including computers that serve websites on the Internet, also have another ID called an Internet Protocol, IP, address. The IP address identifies individual devices on a particular network. IP addresses don't need to be globally unique. On a private network such as a home, business, or school network, the router assigns all the devices on that network an individual IP address that is associated with the device's MAC address. Next, it's also important for you to know that Dynamic Host Configuration Protocol, DHCP, is a technology that's included in modern routers that automatically assigns IP addresses to devices on the network. You can also manually assign IP addresses for mobile devices through the router's network settings or directly on the device if it is acting as a hotspot. The role of the IP address is crucial in the process of sending and receiving data, such as emails. When you send an email, it doesn't travel as a single object from the sender to the receiver. Instead, the email is broken down into smaller units known as packets. Each of these email packets contains not only a portion of the email data but also other information, including IP addresses, which help in its proper routing and reassembly. When you press send, each email packet is guided by IP addresses through the network, jumping from one router to another until it reaches its destination. IP addresses play a key role in guiding email packets and other types of data through the network. Here's a simplified example of a network data packet. How to read the table. Header tells the network where the packet should go and how it should be processed upon arrival. Payload carries the actual data that is transmitted over the network. Trailer carries error-checking information that allows the receiving device to determine whether the packet arrived without errors. You'll notice that the table includes the IP address of the sender and recipient needed to route and deliver the message in the header. Example of an email packet. Header: the header contains the sender's IP address, for example, 64.134.82.111, the recipient's IP address, for example, 64.195.67.134, and the packet number, for example, 1. Payload. The payload consists of the message text, this is a new message. Trailer. The trailer contains the binary data, 110111111. Configuring network connectivity for mobile devices. IT support technicians can configure networks for mobile devices by setting up the proper protocols, security measures, and connection parameters to ensure a secure and efficient network environment. This process is straightforward but requires careful attention to detail and an understanding of both mobile hardware and software components. Introduction. Let's explore the process of setting up network connectivity with Ravi, an IT support technician, who is responsible for preparing new laptops for employees of his company. Step 1. Understand the requirements. Ravi, an experienced IT support technician at a major corporation, is tasked with setting up both wired and wireless network connectivity for a new batch of laptops being delivered to his company. The goal is to ensure that employees can immediately connect to the corporate network and the internet when they power on their laptops for the first time. Step 2. Assess the infrastructure. Before diving into configuration, Ravi assesses the existing network infrastructure. He evaluates the capacity of the existing wired and wireless networks to identify the router and switch capacities, network architecture, and security protocols already in place. Step 3. Configure wired connectivity. To configure wired connectivity for the laptops, Ravi performs the following tasks. Sets up Ethernet ports. He ensures that Ethernet ports are available where needed and that cables are in good condition. Configures IP addresses. He sets up DHCP or manually configures IP addresses, ensuring that they align with the existing network schema. Implements security measures. Ravi configures firewalls and network security policies to safeguard data. Tests connectivity. Ravi tests the wired connections on the laptops to ensure seamless access. Step 4. Configure wireless connectivity. To configure wireless connectivity for the laptops, Ravi performs the following tasks. Selects and sets up access points. Based on the office layout, Ravi strategically places access points to ensure comprehensive coverage. Configures service set identifier, SSID, and security protocols. He sets up the SSID wireless network name and selects security protocols so data is transmitted securely. Sets up authentication. To secure access, Ravi implements authentication measures, which might include connecting to a corporate remote authentication dial and user service, radius, server or setting up individual credentials. Tests connectivity. Ravi tests each laptop's wireless connectivity to ensure it meets the expected performance levels. Step 5. Provide training and documentation. Ravi knows that connectivity can be confusing to some, so he prepares clear documentation and provides training to employees who need it. He explains how to switch between wired and wireless connections and ensures that they know who to contact if they encounter any issues. Summary. Ravi's systematic approach to configuring both wired and wireless network connectivity demonstrates the multifaceted role of an IT support technician. From technical know-how to strategic planning and user engagement, Ravi ensures that the new laptops are ready for immediate use. His attention to detail ensures that employees can connect to essential resources without obstacles, fostering efficiency and satisfaction. Through this project, Ravi not only enables technological readiness, but also adds value to his company by aligning IT infrastructure with organizational goals and needs. Activity: configure wireless network access for an employee-owned device. Employability skills: critical thinking, communication. In this activity, you're an IT support technician at a mid-size architecture firm. Today, you have the important task of setting up wireless connectivity for Sarah, a new employee who has brought her own laptop to work. This is known as a bring your own device, BYOD, scenario. The office space has recently expanded physically, and the company doesn't have coverage in the adjoining office space where Sarah will be working. Sarah is one of a number of new hires. You must complete a few steps to ensure that Sarah can connect her laptop securely to the corporate network. First, you review the BIOD policy and determine factors that need to be taken into account. These include: access to sensitive corporate resources must be restricted to authorized devices only. Devices must meet certain security and software requirements to comply with corporate security standards. All employees must be provided with clear and concise information on how to access the network with their personal devices. After reviewing the company's BIOD policy and reviewing Sarah's needs, you determine that the requirements include: her device should connect automatically to the network when in range. The setup should prioritize ease of use to ensure that Sarah does not require IT assistance. Your supervisor tasks you with configuring additional wireless connectivity in the office to fulfill these requirements. After assessing the infrastructure, it's time to get to work. Step 1. Select and position access points. While assessing the infrastructure, you determine that for Sarah to receive sufficient wireless coverage for her laptop in the office, you need to install a few wireless access points. A wireless access point, WAP, acts as a gateway for mobile devices to connect to a wired network wirelessly. They are like on-ramps that allow wireless devices, like smartphones and laptops, to join the network without physical cables. Sarah does much of her work at her desk in the open space part of the new office area. She also hosts architectural review meetings with clients in a client conference room on site. Finally, she works collaboratively with her peers on designs in a creative workspace. Therefore, Sarah should be able to access the Wi-Fi in any of these spaces. Her desk, client conference room, creative workspace. In the following diagram, explore the layout of Sarah's office space and experiment with the placement of the new access points to ensure comprehensive coverage. Step 2. Configure SSID. Assume that you have set up the access points. Now, it's time to configure the SSID so that data is transmitted securely. In this step, you'll practice the steps in a simulation for network settings. Step 3. Set up security measures. Great job so far! You've chosen where to install additional wireless access points so the area has sufficient coverage and set up the SSID and password. Next, you'll need to set up security measures. Wireless network security is essential for protecting data and restricting unauthorized access. It primarily relies on two key mechanisms: encryption and authentication. Encryption ensures that the data transmitted over the network is scrambled, making it unreadable to unauthorized users. Authentication verifies the identity of devices or users trying to connect to the network. Encryption safeguards your data, and authentication controls who can access the network to begin with. Both are crucial for maintaining a secure wireless environment. Some common security measures include: Wired Equivalent Policy, WEP, uses static encryption keys that are easy to crack. Wi-Fi Protected Access, WPA, uses Temporal Key Integrity Protocol, TKIP, for encryption, which dynamically changes encryption keys for each data packet. Although it's more secure than WEP, WPA with TKIP is no longer considered strong enough for most applications. Wi-Fi Protected Access 2, WPA2, uses the Advanced Encryption Standard, EASE, protocol. EASE uses a more complex encryption algorithm and allows for longer key lengths, providing strong security for wireless data transmission. WPA2 is suitable for both personal and enterprise applications. It's often required for corporate and government wireless networks due to its strong encryption capabilities. Step 4. Communicate instructions. You've successfully configured the network settings, but your job isn't done yet. The final, crucial step is ensuring that Sarah understands how to access the network on her laptop. This is an essential part of any network setup, bridging the gap between technical configuration and practical usage. Your goal in this step is to provide Sarah with the information that she needs to get started at work, specifically how she can access the network, including the SSID and password. In step 2, you wrote down the name of the SSID and the password you'll need to refer to in this step. The following is an email you drafted, and it's almost ready to send to Sarah. Read the email to get familiar with how IT support technicians communicate with users. Type the Wi-Fi network name and password to include in the email, then select Send. Hello Sarah. Welcome to the team. We are thrilled to have you on board and look forward to working together to achieve our common goals. As part of the IT support team, I'm here to ensure that your transition into our work environment is seamless and productive. In today's dynamic workplace, we understand the importance of staying connected efficiently. We acknowledge and support your choice to bring your own device, BIOD, for work purposes. To help you get started, we are providing you with the necessary information to connect your device to our secure wireless network. Wireless network information. SSID, network name _____________________________________________________________________________________________________________________ Shared key, password _______________________________________________________________________________________________________________________ Security is paramount here, and we've taken measures to safeguard our wireless network. Our wireless access points are secured using encryption, providing a robust layer of protection for your data transmission. Connecting to our wireless network is simple. 1. Locate the wireless networks on your device. 2. Choose our network from the list of available networks. 3. Enter the provided password. 4. Enjoy secure and seamless connectivity. If you encounter any difficulties while connecting or have questions related to IT support, please don't hesitate to reach out to our IT help desk. Our dedicated team is here to provide assistance and resolve any technical issues you may face. Once again, welcome. We're excited to have you as part of our team and look forward to seeing your contributions make a positive impact. Best regards. The IT support team. Great work. You've successfully set up wireless connectivity for Sarah. By reviewing the firm's BIOD policy and considering Sarah's specific needs, you have configured an SSID and set up security measures that align with the established requirements and considerations. Sarah's device now seamlessly connects to the network when in range, eliminating any manual hassle. Prioritizing ease of use, you've ensured that Sarah can independently connect to the network without support from IT. The network restricts access to sensitive corporate resources exclusively to authorized devices. In successfully configuring wireless network access, you have contributed significantly to the firm's IT infrastructure, providing a solid foundation for future expansion and the seamless integration of new hires. Summary and looking ahead. In this lesson, you learned about setting up and configuring a business laptop. You also learned about common mobile accessories and various ports that mobile devices use. And you learned about the process IT support technicians follow to configure wired and wireless network connectivity for mobile devices. The next lesson focuses on troubleshooting mobile devices for issues related to their hardware, software, and network connectivity. About this lesson, troubleshooting mobile devices. In this lesson, you'll learn about common issues IT support technicians encounter with mobile hardware, software, and network connectivity. You'll also explore the processes they follow to troubleshoot these issues for mobile devices. Troubleshooting mobile hardware issues. IT support technicians who support mobile hardware such as phones, tablets, and laptops learn to recognize common indicators that signal potential issues. They're knowledgeable about different hardware-related symptoms. 2 people looking at a tablet and sticky notes on a wall. Review the following list of symptoms so that you're aware of situations where hardware can be causing mobile device issues. Sluggish performance, slow response, delayed opening of applications, or constant freezing are usually signs of hardware problems. For example, when a smartphone takes several minutes to open a simple text messaging app, or the keyboard response lags when the user is typing. Overheating. Mobile devices getting hot to the touch can indicate hardware malfunctioning or overuse. For example, after playing a graphic-intensive game for just 20 minutes, a tablet becomes so hot that it's uncomfortable to hold. Battery drain. An unusually fast draining battery might mean battery-related hardware issues. For example, if a laptop's battery, which is rated to last 16 hours, now only lasts 4 hours, even with the same usage pattern, this is a good indication that the battery needs to be replaced. Screen artifacts. Strange lines, colors, or patterns on the screen can indicate display hardware problems. For example, when vertical colored lines suddenly appear across a phone's display, making it difficult to read or view content. Unresponsive controls. If the touchscreen, keyboard, or trackpad is not responding as it should, this might be a hardware issue. For example, the trackpad on a laptop does not respond to gestures, or the response is erratic, causing the cursor to jump around the screen. Unusual noises. Any abnormal noises coming from the device, such as clicking or grinding sounds, can indicate a failing component. For example, when a high-pitched whining sound comes from a tablet, especially when running multiple applications, then there might be a potential issue with internal components. Network problems. Difficulty connecting to Wi-Fi or cellular networks might be a sign of hardware-related network issues. For example, a smartphone constantly dropping the Wi-Fi connection at home, even though other devices are connected without any issues. Physical damage. Cracks, dents, or other physical deformities can affect the internal hardware. For example, a tablet is dropped accidentally, so a large crack appears on the screen, and subsequently, the touch functionality becomes unresponsive in that area. Now that you've explored symptoms that might indicate a mobile hardware-related issue, learn about how to troubleshoot these issues. Troubleshooting mobile hardware. When faced with mobile hardware issues, IT support technicians follow a process to diagnose and resolve the problem. Review the steps that technicians can take to troubleshoot mobile hardware issues. 1. Identify the problem. Understand the exact nature of the problem by asking questions and observing the symptoms. 2. Isolate the issue. Determine whether the issue is with hardware, software, or a combination of both. 3. Inspect hardware. Carefully perform a physical inspection of the device, looking for visible damage or irregularities. 4. Run diagnostic tests. Use specialized software to run tests that can pinpoint specific hardware problems. 5. Check compatibility. Ensure that all hardware components are compatible, especially if the device has had replacements or upgrades. 6. Implement a solution. Apply a solution that fits the findings, adjust settings, clean the hardware, and repair or replace components. 7. Test the solution. Ensure that the implemented solution has resolved the problem without causing new issues. 8. Document the process. Keep a detailed record of the problem, actions taken, and the final resolution. 9. Provide follow-up support. Offer additional assistance and monitoring to ensure that the issue has been completely resolved. In addition to these steps, it's important to stay up to date with the latest technology and trends to prepare for new types of issues that arise. Scenario: the importance of addressing mobile hardware issues. Some mobile hardware issues are annoyances for users rather than substantial issues. However, users experiencing issues that appear to be small in isolation can compound and amplify during heavier use. Consider the scenario of a retailer who failed to address hardware issues early on and the impact that failure had on their business. Background: a major retail chain was using outdated point-of-sale (POS) tablets across their stores. The tablets started showing signs of wear and tear, with sluggish performance and frequent freezes. 1. Identifying the issue. Store employees experienced issues in their daily work, including slow transactions processing and occasional system crashes. These issues were clear signs of the potential hardware problems of sluggish performance and unresponsive controls. Despite the symptoms, management decided not to invest in any of the following: conducting a thorough hardware inspection, running diagnostic tests, upgrading the mobile hardware. 2. Neglecting to diagnose, troubleshoot, and implement a solution. Although IT support was aware of the problems, the team was never approved to prioritize and perform a broad inspection, run diagnostic tests, or implement solutions. Instead, IT support focused on implementing temporary fixes, such as restarting the tablets, without addressing the underlying hardware issues. 3. Experiencing major business consequences. When the holiday shopping season arrived, the problems escalated. Tablets crashed during peak hours, resulting in long lines and frustrated customers. Transactions slowed down, leading to an unhappy shopping experience for many customers and a loss of revenue as some shoppers left the store in frustration. Some customers took to social media to express their dissatisfaction, and the complaints about the outdated and malfunctioning POS systems spread. Competitors seized the opportunity to highlight their more efficient shopping experiences, which further damaged the retail chain's reputation. Lessons learned. Management learned that the diagnosis of issues, proper troubleshooting, and solution implementation are worthwhile investments. A proactive approach to identifying and addressing the hardware problems might have prevented the crisis. This scenario underscores the importance of maintaining hardware in good working condition, especially for critical business operations. Ignoring common symptoms of hardware problems can lead to negative consequences. What do you think? Employability skills. Critical thinking. As you can see, addressing mobile issues early on can prevent these issues from becoming critical. But in this scenario, the retail chain waited. Imagine you're on this company's IT team during the holiday season when the POS tablets failed. What specific steps of the mobile hardware troubleshooting process would you prioritize to troubleshoot and restore functionality quickly? Evaluate your thinking. Does your answer account for the following? In the scenario given, quick fixes like restarting the tablets were already tried and were unsuccessful. If you find yourself in this high-pressure situation, the first step is to isolate the issue to determine whether the problem is widespread or confined to specific tablets or situations. Next, considering that management had previously opted not to invest in thorough testing, you might run diagnostic tests on the hardware to pinpoint issues. For example, do the tablets overheat? Is their screen flickering? Finally, once you've identified the problem, the next step would be to implement a solution. You might need to change out faulty hardware components or adjust settings. After implementation, you should also test the implemented solution. Troubleshooting mobile software issues. One challenge IT support technicians face when troubleshooting mobile devices is determining whether an issue is hardware-related or due to a software failure. Some of the same symptoms can occur for both types of problems. Many times, a device's software will tell users through messages or log files where the issues lie. Although this can help, software can only do what its developers program it to do. When an issue comes up that software or hardware developers didn't anticipate, the line between software and hardware can become blurred. A woman using a mobile phone to scan documents in a tool room. As with hardware, there are some software-related symptoms that IT support technicians can look for when troubleshooting mobile devices. Review the following list of symptoms so you're aware of situations where software can be causing mobile device issues. Frequent crashes. Applications or the entire device abruptly shutting down or restarting can signify software instability. For example, a newly updated email application on a smartphone consistently crashes when attempting to open an attachment, making it impossible to view files. Incompatibility issues. Newly installed applications or updates causing conflicts with existing software can lead to malfunctioning. For example, after a recent operating system update on a tablet, a favorite note-taking app no longer functions properly, rendering previous notes inaccessible. Slow performance. Applications launching or operating slowly, not related to hardware capabilities, can signify a software issue. For example, when a laptop begins to run unusually slow after installing a new antivirus program, even though the hardware specifications exceed the software's requirements. Glitches and errors. Unexpected behavior within applications, including graphical glitches or error messages, can signify an underlying problem. For example, while using a drawing application on a tablet, certain tools cause graphical glitches, leaving unintended marks on the artwork. Security warnings. Alerts or suspicious activities can indicate potential malware or other security breaches. For example, a smartphone starts showing security warnings from the installed firewall, indicating potential unauthorized access attempts after the downloading of a suspicious app. Drain on resources. Unusually high usage of system resources like memory or the central processing unit, CPU, even when running simple tasks, can signify a software issue. For example, a weather widget on a laptop starts using an excessive amount of CPU and memory, slowing down other applications even though it's a lightweight program. Connectivity issues. Difficulty connecting to networks or peripheral devices not related to hardware components can signify a problem with the device. For example, after a system update on a smartphone, the Bluetooth connection to wireless headphones becomes unstable, frequently disconnecting even though the hardware is in good condition. User interface, UI, problems. Layout issues, unresponsive buttons, or other interface-related problems within applications can indicate a system issue. For example, an online banking application on a tablet displays overlapping text and buttons after an update, making it difficult to read information or make selections. Now that you've explored symptoms that might indicate a mobile software-related issue, learn about how to troubleshoot these issues. Troubleshooting mobile software. By carefully examining the signs of software issues and following a systematic troubleshooting process, IT support technicians can identify and resolve most software-related problems on mobile devices. Because symptoms of software and hardware issues can overlap on mobile devices, IT support technicians need to rule out hardware issues before turning to the software as the cause. After ruling out hardware, technicians can apply software-specific troubleshooting methods to identify and isolate mobile software issues. Review the following steps that technicians can take to identify and isolate mobile software issues. 1. Check software versions and updates. Verify that all software, including operating systems and applications, are up to date and compatible with each other. 2. Run software diagnostic tools. Use software diagnostic tools to check for common errors, corrupted files, or other issues. 3. Review logs and error messages. Analyze system logs and error messages to pinpoint the underlying cause of the problem. 4. Reproduce the issue. If possible, recreate the problem on a different device of the same model to understand the circumstances under which it occurs. After the problem has been identified and the technician has isolated the issue as a mobile software issue, they can follow the same steps used for troubleshooting mobile hardware. 5. Implement a solution. Depending on the diagnosis, reinstall or update software, adjust settings, or remove conflicting or malicious software. 6. Test the solution. Ensure that the implemented solution has resolved the problem without causing new issues. 7. Document the process. Keep a detailed record of the problem, actions taken, and the final resolution. 8. Provide follow-up support. Offer additional assistance and monitor to ensure that the issue has been completely resolved. In addition to these steps, regular maintenance, updates, and attentive monitoring can help minimize software issues and ensure a smooth user experience. It's also important to keep up with software developments through additional education and training. Scenario: active software troubleshooting alleviates issues. Mobile applications are a vital part of people's daily lives, making the accuracy and reliability of these platforms very important. When software glitches happen, the way a company responds can deeply impact user trust and satisfaction. Let's explore a scenario in which a location tracking glitch occurred with a ride-sharing company's mobile app after a new update. Notice how their proactive approach to troubleshooting this software issue on mobile devices led to a successful resolution and increased user satisfaction. Background: a well-known ride-sharing company released a new update to its mobile app that was designed to enhance the driver and rider user experiences and provide more accurate location tracking. However, shortly after the update, users began to experience inaccuracies in their location being displayed within the app, causing confusion for both riders and drivers. 1. Identifying the issue. The company identified the issue when a significant number of users reported their location being displayed incorrectly within the mobile app. This problem occurred across various types of mobile devices, including smartphones and tablets. 2. Analyzing the issue. Upon receiving the complaints, the ride-sharing company's IT team promptly realized the gravity of the situation. Given that the issue manifested across a variety of mobile devices, the team was able to rule out a hardware-related problem. This evidence suggested a software glitch as the root cause. Recognizing the complexity of the issue, the IT team escalated the problem to the software engineering team for a more in-depth code review, aiming to resolve the location tracking discrepancies. 3. Diagnosing the problem. Using diagnostic tools and careful examination, the team identified that the recent update had introduced a conflict with certain GPS functionalities within some mobile devices. The engineering team and IT team worked with the quality assurance (QA) team to reproduce the issue across various devices and operating systems. Together, they identified the root cause of the issue. 4. Implementing and testing the solution. Once the teams determined the root cause, the software engineering team developed a fix to correct the code and restore the accuracy of the location tracking feature. QA performed rigorous testing to ensure that the solution was effective and would not introduce any additional problems. 5. Communicating with users. The company communicated transparently with its users, acknowledging the issue and providing regular updates on the progress of the resolution. They also offered promotional discounts to impacted users as a gesture of goodwill. 6. Results. By swiftly applying the appropriate troubleshooting steps, the company fixed the location tracking glitch in their app within a short period. Their quick response and clear communication resolved the issue and strengthened their relationship with users. Customer satisfaction increased, and they restored trust in the app's reliability. Lessons learned. This scenario illustrates the power of proactively troubleshooting mobile software issues. By recognizing the signs of a software issue and applying systematic troubleshooting steps, the ride-sharing company quickly resolved a potentially damaging problem. Their success underscores the importance of responsive and effective troubleshooting in maintaining the integrity of mobile applications and the satisfaction of users. This scenario serves as an example of how proactive troubleshooting techniques can lead to positive outcomes. It also shows the critical role IT support technicians play in helping keep mobile device software working properly. What do you think? Critical thinking. Evaluate your thinking. Does your answer account for the following? In this scenario, you might have taken these steps. Check software versions and updates, ensuring all software, including operating systems and the mobile app, are fully updated and compatible might be a good first step. Run software diagnostic tools. Use software diagnostic tools to quickly identify common errors or corrupted files that might be affecting the location tracking feature. Review logs and error messages. An in-depth analysis of system logs and error messages might also help the team to pinpoint the root cause of the GPS discrepancies. Log files can be beneficial for identifying hardware issues, and they are also useful for identifying issues with software and applications. When software has issues, users typically know about it because the software crashes or stops working and shuts down due to a bug or series of bugs. However, it can still be difficult to pinpoint the source of the problem. You can use log files to quickly determine if the issue exists in the application that is crashing, the operating system, or other software, such as a networking application. Log files are computer-generated files that contain a record of everything that happens within a system, including information about operations, activities, and usage patterns. Many operating systems come with basic diagnostic software and command line interface commands that IT support technicians can use. There are also many third-party tools that offer more features and capabilities. Review log files. Let's review how to analyze log files, specifically for software issues. Log files produced by diagnostic tools can contain a lot of information that can be difficult to decipher. Thankfully, most log files include keywords that you can use to determine whether the software is operating properly. Examine this example entry from a diagnostic tool that illustrates the issue of a failed document download on a secure corporate network. Entries from a log file from a mobile device. Here is the extracted data converted into a chronological narrative. On August 29, 2023 at 10 hours 1 minute and 2 seconds, a login event occurred as the user logged in using corporate credentials. On August 29, 2023 at 10 hours 1 minute and 15 seconds, a navigate event occurred when the user navigated to the document repository. On August 29, 2023 at 10 hours 1 minute and 23 seconds, a select file event occurred as the user selected quarterly_report.pdf. On August 29, 2023 at 10 hours 1 minute and 28 seconds, a download initiated event occurred, and the download of quarterly_report.pdf was initiated. On August 29, 2023 at 10 hours 1 minute and 30 seconds, an SSL handshake event occurred, and the SSL handshake started. On August 29, 2023 at 10 hours 1 minute and 31 seconds, an SSL handshake error event occurred because the SSL handshake failed. On August 29, 2023 at 10 hours 1 minute and 32 seconds, a download failed event occurred, resulting in the download of quarterly_report.pdf failing. What can you conclude from the log file? Notice that the user was able to log into the application, but after initiating a download of the quarterly report document, there was an SSL handshake error. When you've determined that the software has an issue, you can determine the next steps. For instance, a secure sockets layer, SSL, handshake error occurs during the initial phase of establishing a secure connection between the user's device and the server. The handshake is a series of steps where both the device and the server agree on the encryption algorithms they will use, exchange key information, and verify the identity of the server, and sometimes the user. When the handshake fails, it means that a secure channel could not be established, and any data transmission, such as a document download, would also fail. The error can be due to various reasons, such as a bug in the application, outdated security protocols, or issues with certificates. Use log files for quick insights. You can use diagnostic tools and the log files they produce to get quick insights into what otherwise might be obscure issues. If the logs are unclear, you can post files to user groups on the internet or send log files to other IT support technicians to help you determine whether your hardware has problems or not. Ruling out or confirming substantial software problems using logs can help you focus on the right things. Activity: troubleshoot a mobile device issue. Employability skills. Critical thinking. In this activity, you're new to your role as a new IT support technician at a leading cybersecurity firm. Today, you're shadowing Nandita, an experienced IT support technician who's been with the company for several years. Nandita is well regarded for her expertise in troubleshooting and problem solving, particularly when it comes to mobile device issues. You'll be observing and assisting Nandita as she works on a support ticket from Emil, an employee who's experiencing an issue with a mobile device. This is a great opportunity to gain experience in how to diagnose and resolve real-world IT issues. You'll explore how to follow the steps to troubleshoot a mobile device issue. Use a log file to diagnose and resolve a mobile device issue. As Nandita navigates the troubleshooting steps, pay close attention to how she interacts with Emil and how she uses log files to identify and fix the problem. The support ticket. A group of IT support technicians working at computers. The chatbot connects Nandita with her first ticket of the day. She opens the request in the system and records the date and the client's contact information. It's time to start a chat with the client to gather information about the client's issue. Step 1. Identify the issue. Emil connects over chat and tells you that after a recent software update on his mobile device, he's unable to access his corporate email application while connected to the corporate Wi-Fi network. Nandita begins by introducing herself and getting some basic information about Emil's issue. As she continues chatting with Emil, you learn that Emil recently received a software update for his laptop. Emil is not receiving new emails and cannot search older emails on his email application when on corporate Wi-Fi. The app functions normally on other networks or when using mobile data. He has restarted his laptop and the app multiple times, but the problem persists. Emil reached out for support because he urgently needs to access his work email. You and Nandita have some initial information from Emil, but you need to explore the issue further. You need to gather more information to incorporate into your evaluation of the problem. Nandita requests the device's make, model, and operating system. She also asks what network he is on when the problem occurs. Finally, she asks some basic troubleshooting questions, like the last time he experienced the issue. Now that you have more information from the client regarding the issue, Nandita begins to determine if she can rule out a hardware issue. Based on the symptoms, you tell her that you believe it is a software-related issue. Nandita agrees with you. Step 2. Begin to analyze the issue. The next step is to analyze the issue Emil is experiencing. At this point, the goal is to identify potential root causes and determine the best course of action for troubleshooting. Nandita begins to analyze the issue by verifying the versions of all software on Emil's laptop, including the operating system and the corporate email application in question. To do this, she 1. Checks operating system version. Nandita asks Emil to provide information on the current version of his laptop's operating system. She compares this information with the latest version available, as listed on the manufacturer's website. 2. Verifies email application version. Nandita then inquires about the version of the corporate email application Emil is using. She cross-references this information with the latest update available on the company's internal software update portal. 3. Cross-checks with patch notes. To be thorough, Nandita also reviews the patch notes for the latest software and application updates. She's determining if any recent updates should have addressed or potentially caused the issue Emil is experiencing. After completing these verification steps, Nandita finds that both the operating system and the corporate email application on Emil's laptop are up to date. The patch notes do not indicate any known issues related to the symptoms Emil has described. Step 3. Review logs. Having verified that all software is up to date, Nandita's plan is to now examine the device's log files for more insights into the issue. Nandita remotely accesses Emil's laptop to access the log files from his email application. Take a moment to review the log file to conclude whether you can find an entry that indicates an error. Here is the extracted data from the system log table, converted into clear, chronological sentences. On August 28, 2023 at 9 hours 45 minutes and 21 seconds, a default event occurred under process ID 89 where the Wi-Fi connected and successfully connected to corporate_Wi-Fi. On August 28, 2023 at 9 hours 46 minutes and 5 seconds, a default event occurred under process ID 87 involving an email login where the user initiated login to the corporate email application. On August 28, 2023 at 9 hours 46 minutes and 10 seconds, an error occurred under process ID 72 stating that the SSL handshake failed, resulting in a failure to establish a secure connection to the email server during login. On August 28, 2023 at 9 hours 46 minutes and 15 seconds, a default event occurred under process ID 87 involving an email login where the user initiated login to the corporate email application. On August 28, 2023 at 9 hours 46 minutes and 20 seconds, a default event occurred under process ID 88 where the Wi-Fi disconnected, indicating the device disconnected from corporate_Wi-Fi. On August 28, 2023 at 9 hours and 47 minutes, a default event occurred under process ID 89 where the Wi-Fi connected and successfully reconnected to corporate_Wi-Fi. On August 28, 2023 at 9 hours 47 minutes and 10 seconds, a default event occurred under process ID 87 involving an email login where the user initiated another login to the corporate email application. On August 28, 2023 at 9 hours 47 minutes and 12 seconds, an error occurred under process ID 72 stating that the SSL handshake failed, resulting in a failure to establish a secure connection to the email server during login. On August 28, 2023 at 9 hours 47 minutes and 15 seconds, a default event occurred under process ID 87 involving an email login where the user initiated another login to the corporate email application. Step 4. Next steps. Nice job! You and Nandita have listened to the client and asked helpful follow-up questions. In addition to the information you gathered at the beginning of the conversation, you now have additional data about the problem from reading the log files. You've learned that 1. Emil recently received a laptop software update. 2. Emil is not receiving new emails and cannot search older emails on his email application when on corporate Wi-Fi. 3. The operating system and the corporate email application on Emil's mobile device are up to date. 4. The issue is software related and appears to be an incompatibility issue. 5. The log file shows an SSL handshake failure error. Now that you've gathered a substantial amount of information about Emil's issue, the next step is to formulate a strategy to resolve the problem effectively. Nandita takes the lead, and you're eager to learn from her experience. Nandita shares that the SSL handshake failure usually relates to secure communications, which the corporate email app relies on to connect over Wi-Fi. Given that the software and the email application are up to date, it might be a newly introduced bug. Nandita sends a detailed report to the corporate email application's vendor support for expert insights. Nandita receives a prompt response from vendor support confirming that the issue is indeed a known bug. They offer a workaround until the next software update, which includes tweaking certain settings on the email app to bypass the SSL handshake failure. Step 5. Resolving the issue. Now that you have a viable solution, it's time to implement the workaround fix and confirm that it resolves Emil's issue. Nandita starts a new chat with Emil to share that she knows what is causing his issue. She remotely accesses his laptop and performs the steps of the workaround, including adjusting specific settings in the corporate email app. After the settings are updated, Nandita asks Emil to try accessing his email over the corporate Wi-Fi network. Emil confirms he can now receive new emails and search older emails without any issues. Nandita also checks the log files to confirm that the SSL handshake failure is no longer occurring. Well done! You successfully followed and helped Nandita to successfully diagnose and troubleshoot this mobile software issue. Networks connect people and data through devices. Many variables can impact data transmission over a network. Some network connections are wired, and others are wireless. Most mobile devices support and use wireless networks. The following illustration depicts a simple network with a tablet connected to a router by Wi-Fi and a wired smart television. A network with a tablet that uses Wi-Fi, a router, and a smart TV connected to the router with a wire. Wireless network connections utilize radio signals to transmit data between two network nodes, usually comprised of a sender and receiver device. These connections are commonly associated with Wi-Fi networks. Note: devices such as mobile phones also use cellular technology that transmits data to and from the device to radio towers managed by cellular phone companies. Wired network connections use a cable to transmit data between two network nodes. Ethernet is the most common wired network connection. It's important to keep in mind that networks can be a mix of both wireless and wired connections. Common issues for wired and wireless networks. IT support technicians frequently encounter a variety of issues related to both wired and wireless networks. Whether they are providing support for a large corporate setting or a small home office, understanding the common issues that can plague these networks is vital for quick diagnosis and repair. From problems at the individual node level to issues with network settings, technicians need to be prepared to tackle challenges that come their way. Problems at the nodes. Sometimes, network connections might experience failure due to issues with specific nodes. These nodes, which could be either the sending device or the receiver, are potential sources of connectivity problems. In wireless networks, the wireless network card in a device, which requires a driver to function, could be problematic. A driver is software that controls the hardware. If a driver has a bug or flaw in the code, then it can impact the ability of a wired network to send or receive data. In the case of wired networks, issues might arise from the network interface card, NIC, within the computer. Drivers that control the NIC could be outdated or incompatible, leading to failed transmissions. For example, an IT support technician might notice that a specific computer in an office setting cannot connect to the network. The technician would then check the driver settings for the wireless network card, update the driver if needed, and restart the computer to resolve the issue. Issues with the router. A router routes data, or controls traffic, from one network to another. For example, the router enables the transfer of data from the internet to your home network. In both wireless and wired networks, routers might malfunction and cause issues. Issues might arise if a router is placed in a location with physical obstructions, such as walls or metal filing cabinets. Or a router's DHCP settings might be misconfigured, preventing it from assigning IP addresses to new devices. For wireless networks, a malfunctioning router can lead to a complete loss of wireless internet access for all connected devices. In wired networks, the router's failure would mean that no device connected through Ethernet could access the external network. For example, an IT support technician might find that the office's internet connection is down. Upon investigation, they discover that the router is not syncing with the Internet Service Provider, ISP. Resetting the router or contacting the ISP to troubleshoot would be likely courses of action. Problems with transmissions. Transmission issues are problems that occur when data is being sent or received over a network, affecting the integrity or speed of the data exchange. These issues can disrupt the efficient flow of data between devices and might result in slow speeds, packet loss, or complete network failure. Packet loss is an issue that causes part of the data stream to be lost. Transmission issues can arise due to a variety of factors, including poor connections and hardware malfunctions. With wireless networks, radio signal interference from other electronic devices can result in unstable network traffic. In wired networks, damaged or improper cabling can affect communications. For example, an IT support technician might find that data is not flowing smoothly within a wired network. By running diagnostic tests, they might identify that a specific Ethernet cable is damaged. Replacing the faulty cable would resolve the issue. Issues with network settings. Issues with network settings can cause many problems, primarily affecting a device's ability to connect to a network or maintain a stable connection. These issues often stem from incorrect transmission control protocol/internet protocol, TCP/IP, settings on the device in question. In wireless networks, incorrect TCP/IP settings can be especially problematic, preventing a device from connecting to the correct wireless network. This can also result in unstable or slow connections, disrupting everyday tasks such as sending emails or browsing the web. For wired networks, similar issues can manifest, such as when a technician manually sets up IP addresses and mistakenly configures two devices on a wired network with the same IP address, leading to IP address conflicts. This usually causes connectivity problems for one or both of the devices involved. Consider a scenario where an IT support technician receives a complaint from an employee who can't connect their laptop to the company's network. Upon investigating the laptop's network settings, the technician discovers that the IP address is already in use by another device on the network. To solve this, the technician manually assigns a new, unique IP address to the laptop, thereby resolving the conflict and restoring network connectivity. Troubleshooting network connectivity. Let's focus on how IT support technicians troubleshoot network issues for mobile hardware. Although troubleshooting network connectivity issues follow the same general process as troubleshooting mobile hardware and software issues, there are two additional factors to consider. Rule out individual client devices. Consider environmental conditions for wireless networks. Rule out client devices. Overhead view of people sitting at a table using multiple devices, including laptops, smartphones, headsets, and chargers. A client device is a user device, such as a computer, smartphone, or tablet, that uses network hardware and services to connect to a network. A network connection transmits data between two or more devices, including client devices such as a laptop and network hardware such as a router. When IT support technicians encounter network problems, they often begin by checking the client devices first to help them rule them out as the source of the problem. Once client devices are ruled out, the technician can begin troubleshooting the network. Explore specific areas you should check to find network issues in wireless and wired networks. Check the hardware. Hardware integrity is a cornerstone of network reliability. A loose or damaged cable can impair network functionality. In wireless networks, technicians should check to determine whether routers and wireless access points are damaged or unplugged. For wired networks, technicians should start by examining cables for frayed wires or damaged connectors. They should also ensure that cables are securely plugged into the network adapter. Consider a scenario where an IT support technician notices sporadic network outages in a department. After verifying that the issue isn't widespread, they inspect the physical connections and find a frayed Ethernet cable. Replacing the cable resolves the problem. Check the network adapter. The network adapter serves as the interface between the device and the network. Its settings and drivers need to be up to date for optimal performance. Technicians should check the history to see if software or drivers were updated recently. Rolling back a device driver can help you troubleshoot issues in these cases. Check the settings because routers assign IP addresses to network adapters. The adapter must be set to automatically get this address. An improper setting can prevent the router from properly assigning an IP address to the adapter. For wireless networks, technicians should confirm that the network adapter is enabled and set to automatically connect to known networks. For wired networks, technicians make sure the network adapter settings are configured to obtain an IP address automatically. Consider an example where an IT support technician finds a computer that can't connect to the network. They inspect the network adapter settings and notice an outdated driver. Updating the driver restores the connection. Check workplace software for conflicts. Many workplaces require the installation of management software on employee devices. This software ensures that company resources are kept safe by preventing users from installing certain pieces of software, monitoring network traffic, and preventing access to certain websites and other services. However, if the management software has a bug or is incorrectly configured, it can interrupt network traffic. In both wireless and wired networks, technicians should check whether the management software is configured correctly and isn't blocking essential network traffic. They can verify that the list of authorized devices matches the actual devices in use and examine logs for any irregularities that indicate incorrect configurations. Consider an IT support technician who identifies that a specific department is experiencing slow network speeds. They discover that the management software was mistakenly throttling network traffic, and they adjust the settings accordingly. Check VPN settings. Virtual Private Network, VPN, software enables devices to access the company's network securely. When a device is connected to a corporate network through a VPN, specific network traffic is routed through the VPN software. Incorrect software settings or buggy software can interrupt network traffic or make it unstable. For both wireless and wired networks, technicians should ensure that the VPN software settings are correct and that the application is routing traffic properly by reviewing the settings in the VPN software. They should verify server location to ensure it aligns with intended use cases and confirm encryption settings for optimal security. For example, an IT support technician might receive a ticket regarding intermittent disconnection issues when an employee tries to access internal company resources. The technician would initiate a remote session with an employee's computer, navigate to the VPN software settings, and confirm that all configurations are in line with company protocols. If they find any incorrect settings, the technician can adjust them and then perform a test to confirm that the VPN connection is stable and secure. Check the firewall. Most devices have firewall software that prevents certain types of network attacks. The firewall can close ports, which are channels by which networks communicate with each other. If a firewall isn't configured properly, it can prevent valid traffic from getting through. In both wired and wireless networks, technicians should verify that the firewall settings are not blocking essential ports or network services. Technicians should access the firewall settings, review the list of open and closed ports, and review the settings that control port access. Consider a situation where an IT support technician is alerted to an issue where internal team members can't access a web-based tool hosted on a company server. The technician logs into the firewall management dashboard and reviews the port settings. They discover that port 443, essential for secure web traffic, is mistakenly blocked. After updating the setting to allow traffic through port 443, the technician tests to confirm that access to the web-based tool is restored, thereby resolving the issue. Network connections involve many layers of software and hardware that enable them to work properly. Starting with the devices connected to the network provides IT support technicians a foundation upon which to begin to troubleshoot the problem. Consider environmental conditions for wireless networks. Not so long ago, cars lacked the technology for satellite radio or the ability to connect to mobile devices to stream music or podcasts. Travelers often used AM and FM radio to listen to music and talk radio, a precursor to podcasts. AM and FM signals can have a hard time finding their way through tunnels on the road, so the sound would often turn to static. Because wireless networks use radio signals to communicate, they are subject to environmental challenges. Today's wireless routers are particularly good at accommodating radio interference, but something like a microwave oven can still significantly interfere with the radio signals. IT support technicians need to take environmental factors into consideration when troubleshooting. Here are a couple of considerations to keep in mind. Think about the physical environment. Wireless radio signals can be impacted by corners, walls, and even the material in the walls. Distance from the router also impacts how strong a signal is. For example, the signal from a router located in a bedroom might not reach the backyard. Router manufacturers have tried to address these issues by creating routers that use repeaters to amplify the signal. Be aware that the location of the wireless router can impact how fast and stable the network connection is. Think about signal interference. Wi-Fi technology continues to improve, and many of the problems that affected early versions of wireless routers have been solved. But, because Wi-Fi uses radio signals, problems might still show up. IT support technicians must consider wireless network layouts and be aware of ways to solve network problems that are particular to wireless networks. For example, if people in an apartment complex all have their own wireless routers, the signals might interfere with one another. The Wi-Fi specification describes the maximum signal strength for wireless radios and how to use channels to modify the frequency signals used to travel. This information helps address interference issues. Even so, interference in high-density environments can be a problem. Know how to look for and properly set channel frequency to solve certain types of problems. Much like troubleshooting mobile hardware and software issues, troubleshooting mobile networking issues can be complex and challenging. By ruling out client devices and considering environmental conditions for networks, IT support technicians can troubleshoot network connectivity issues more efficiently and effectively. The troubleshooting steps you've learned that IT support technicians apply to mobile hardware and software issues are also applicable to troubleshooting network connectivity issues for mobile devices. Activity: differentiate between hardware, software, and network connectivity issues. Employability skills. Analytical thinking. You've learned about common issues and troubleshooting steps that IT support technicians follow for mobile hardware, software, and network connectivity problems. In this activity, you'll review a short scenario about a mobile device and choose the type of issue you need to troubleshoot. Summary and looking ahead. In this lesson, you learned about troubleshooting mobile devices. You learned about symptoms that IT support technicians examine when identifying issues with mobile hardware and software. You learned about specific factors technicians consider for mobile network connectivity, including ruling out client devices and environmental conditions. You explored the processes to follow to troubleshoot hardware, software, and network issues for mobile devices. You've completed the final lesson of this module. Next, you'll review the module's key points and explore additional resources related to mobile hardware and troubleshooting. Points to remember. Key concepts. 1. Mobile hardware is designed for portability and offers the user flexibility and accessibility, and desktop hardware is used in a fixed location, offers higher processing power, and is customizable. 2. Mobile devices such as smartphones, tablets, and laptops enable remote work, making it possible for employees to access company data, collaborate anywhere in the world, and be productive. 3. Mobile hardware components include display technology, such as LCD, OLED, and AMOLED. Physical buttons and interfaces. Cameras and audio components. Batteries and charging technologies. Wireless connectivity, such as Wi-Fi, Bluetooth, and NFC. Sensors, such as accelerometers, GPS, and biometric sensors. 4. Setting up and configuring a laptop includes inspection, OS setup, software installation, network configuration, customization, and security and compliance considerations. 5. IT support technicians must be knowledgeable about the wide range of mobile device displays, including resolution and size considerations, technology differences, unique display types, and compatibility issues. 6. Accessories are a key part of mobile devices. Accessories provide protection, audio, charging, connectivity, input, and health monitoring. 7. Mobile device ports allow for charging, data transfer, audio output, expansion, and cellular activity. 8. Wired connections often provide faster and more reliable speeds than wireless connections, which offer the flexibility of accessing the network from various locations. All network-connected devices have a MAC address and an IP address. 9. MAC addresses are globally unique, so no two pieces of hardware can share the same address. IP addresses, on the other hand, do not need to be unique. 10. Symptoms that can indicate a mobile hardware issue include sluggish performance, overheating, battery drain, screen artifacts on the display, unresponsive controls, unusual noises, network connectivity problems, and physical damage. 11. To troubleshoot mobile hardware issues, IT support technicians should identify the problem, isolate the issue, inspect hardware, run diagnostic tests, check compatibility, implement a solution, test the solution, document the process, provide follow-up support. 12. Symptoms that can indicate a mobile software issue include frequent crashes, incompatibility issues with applications, slow performance, glitches and errors in applications, security warnings, drain on resources, connectivity issues, and UI problems. 13. IT support technicians should perform the following additional steps to isolate and troubleshoot mobile software issues. Check software versions and updates. Run software diagnostic tools. Review logs and error messages. Attempt to reproduce the issue. 14. Common issues for wired and wireless networks for mobile devices include node, router, transmission, and network settings issues. 15. Troubleshooting network connectivity issues follows a similar process to that of troubleshooting mobile hardware and software issues, and technicians should also rule out client devices and consider environmental conditions for wireless networks. Big ideas. In addition, you explored or practiced these skills. Employability skills. Analytical thinking. Describe how an IT support technician supports a remote user on their mobile device. Explain ways an IT support technician can prepare a mobile workforce. Review log files to determine the cause of a mobile issue. Communication. Prepare an email to communicate technical information to a client. Critical thinking. Explain the importance of mobile hardware in today's work environment. Explain the benefits and challenges of using mobile hardware. Categorize challenges IT support technicians can encounter when supporting various mobile displays. Describe how different mobile devices can address the needs of people working in remote jobs. Describe the process of setting up a laptop. Describe the process of troubleshooting mobile hardware. Describe the process of troubleshooting mobile software. Differentiate between mobile hardware, software, and networking issues. Documentation. Document information while configuring a wireless network. Problem solving. Configure wireless network access for an employee-owned device given specific requirements. Explore more resources. To explore concepts covered in this module in more depth, check out these resources. From the brick to new foldable phones, the history of the mobile form factor, opens in a new tab. This blog by Jack Melling for the ARM community provides a summary of the development of the mobile form factor for devices. What is mobile technology? Opens in a new tab. This article by IBM discusses the different types of mobile networks and key capabilities of effective mobile technology. Configure IP network connectivity, opens in a new tab. This online module by the Microsoft Corporation explains how to set up and configure IP networks.